Hello, everybody. Welcome you to our webinar. Today we'll talk about traffic enforcement, and we'll describe you what we have done in the past months to merge visibility and cybersecurity. We want to stay as a company that monitors traffic, but we see value in enforcing traffic. This is an important topic for many people. In the past, we have done some developments for home users and for ntop users, enrich. I will be talking about that, and we want to describe you what are our plans in this area, in particular for cybersecurity. And of course, we need your feedback, because for us it is important to listen to our community and to understand, if we are able to interpret your needs or not. Okay, let's start with ntop. 20 years ago, I have personally started the development of ntop, the original ntop that is now called ntop-ng. And as you can see, many things have changed. But if you look at the web interface, it is totally different. There are things that are now, dead, such as the old HTML or the old WAP terminals. So the story is very different in terms of protocols. Some protocols don't exist anymore, and so on. But if you look at the traffic, you see that many things have changed. In particular, the packet inspection is becoming an important ingredient today to understand what is happening in our network. And this is very important because traffic is encrypted. Traffic needs some sort of interpretation. So we cannot simply say TCP port 80 means HTTP. We need something much more than that. And at the same time, we see the trend in security, in particular in cybersecurity, that is becoming more and more important for many people, because security threats, unfortunately, are very popular. And this means that, for many people, this is an important argument to understand. So we would like to merge, in essence, what we have done with visibility, also with traffic enforcement, without being, let's say, too oriented in enforcement. So we simply want to complement, add another, piece, okay, for those who believe it is important to an existing environment. And we also want to demonstrate, this is something that my colleagues, Matteo and Alfredo, will do in the second part of this talk, what we have done with platforms such as OPNsense and pfSense, that are two of the most popular security-oriented platforms that are used today. Okay, so in essence, in 20 years of network monitoring, things have changed drastically in terms of speed. So today, 10 gigabit is commodity for companies, for many companies, 100 gigabit for ISPs, whereas 20 years ago the story was totally different. But if we look at the network monitoring protocols, we still see that NetFlow and SFlow are the protocols. I don't want to mention here SNMP because this is more for device monitoring, whereas in this presentation we'll focus more on traffic monitoring. So the only difference with respect to 20 years ago is that the networks are faster. But at the end of the story, if I look at many companies, so if you Google companies that are doing traffic monitoring, many of them are still talking about bytes and packets. But like I've said, these are two important metrics, the basic ones, but they are not enough today, in particular with encrypted traffic with cyber threats. So therefore, we need something more than that. That's why we said, why don't we complement what we have already done, so network monitoring or observability, if you wish, with something that is more oriented to cybersecurity. Observability is the way to, in essence, to ask any question to your system and to be able to see and to understand what has happened in a network. However, this is not enough, because we need to also to understand from the security standpoint what is happening. So cybersecurity is a popular topic today, and we need to to let's say give more importance to this type of questions that many people have. If you look at the backbone, so we believe that there is some sort of protection that is basically granted for everyone. I don't want to say it is working all the time, because when we talk about volumetric attacks, we talk about mitigation. So they are not solutions, but they are a way to somehow to find to circumvent a problem that some people create, okay, by attacking other people with a lot of traffic. So in a way, basic protection is available for everyone. But this is it's good for ISPs, for carriers, whereas for companies, where is basically the place where ntop is actually active, the story is different, because threats happen there, and most of the threats are happening there today. So we want to be able to somehow offer some sort of protection, capitalizing on the work we have done in the past years to our community. So in essence, we want to focus on the network edge, where the speed it is increasing. So whenever there is a threat, the threat can be a big threat for many people, in particular with remote workers that are now no longer at the premises, at the company premises, so that it is hard to understand what is happening at the edge. It's becoming, let's say, more and more complicated. So we want to make sure that unhealthy traffic, it is somehow restricted, and that this traffic is somehow used to create some sort of score value that we can use to decide whether there is something bad happening in our network that we need to block. And this is something we want to do in an unobtrusive way. So it means that we don't want to record everything, dump it into a database, store information about users. This is not our goal. I will be sure later in this presentation that what we are doing, it is basically based on statistical methods, and those methods are based on numbers. So we don't want to store values unless you really want to do that. So in essence, we want to be able to give everyone the ability of understanding that there is something wrong in our network, and to understand who is creating the problem, without having us to dump every single byte and packet of this person, of this host, in a database, because we believe that it's important to create a healthier network without violating users' privacy. And the key ingredient today is NDPI, that is a DPI toolkit. I personally started to develop based on an existing, maintained DPI toolkit, or let's say code that was available on the internet. And since then, so it's about 9 years that we are developing it. Since then, many things have changed, because all the ntop tools are based on NDPI. This is because NDPI is the first layer that allows us to understand what is happening in the traffic and what type of information it is present, not just from the application standpoint, that is the original goal of the packet inspection, but also from the point of view of the behavior of the communication. And this is something that I will be describing later in this presentation. So when I say NDPI, don't think NDPI as a way to detect the application protocol, but think of it as a way to label the information. And if you are familiar with machine learning techniques, so in a way, you can call it a feature extractor, because it can characterize the traffic, and report features about the traffic, in particular from the cybersecurity standpoint, to applications. And in our case, we are the consumers. So NDPI is totally open source. So ntop and GM Probe and our tools are using it. But you can also capitalize on that if you have developed your own toolkit. In NDPI, the basic principle is the following. So we want to understand what is the application protocol, layer 4 and layer 7. And we want to put a label next to it that says whether this traffic is good or bad. And so in essence, we want to understand what is the value of this traffic, what type of information is carried by this protocol, if possible, and then based on that, make a decision. And in cybersecurity, most of the traffic being encrypted, we see challenges, but at the same time, we have developed not just because of ntop, but also because of the many contributors to the project. Because I remind you that NDPI is open source, the code is on GitHub. We have been able to implement many techniques for dissecting encrypted traffic, not just for decoding, but for understanding the basic metadata, the basic information that we can use to fingerprint the traffic and to understand if there is something bad happening. In particular, we have the techniques, part of NDPI, that allows you to spot DGAs, or domain-generated algorithms, if you wish, JE3, that is a way to label client and server TLS. We have the ability in NDPI to support the blacklist, so that there are many companies that every day create a blacklist of IPs that are misbehaving. And this is an important way, for instance, to remove pollution in our network without doing many things. But our goal is not just to rely on a blacklist, but it's also to base our work on the behavior and on the observation of the traffic. So because of that, we have introduced the concept of risk with a flow. That in essence, that is a way for us to label this traffic and to associate a label that says this traffic is good, this traffic is bad, or this traffic it is very bad. And based on that, we draw some conclusions that allows us to say, okay, the host that is making this traffic is under attack, or is attacking somebody else, or they say this host is healthy. So this is the basic principle. And the risks are manifold. So this is the list of currently supported in NDPI. And as you can see, I put some colors here. In the blue labels, we will see risks that are pure for encrypted traffic. So it means encrypted and plain traffic. So it means that those risks belong to both protocols. In red, so you will see that there are many. They are encrypted only flow risks. So it means that we have put a lot of time not just to understand clear text protocols that are kind of simple or legacy, if you wish, but also to understand the nature of the encrypted communication. We have done some tests on internet backbones or internet traffic, and we see that today in our test about 80% of the traffic is encrypted. Internet traffic is encrypted. So it means that we need to focus there. So the remaining 20%, it is somehow legacy, and it is slowly decreasing. It will not become zero for sure, but it will become less and less. So we need to focus on encrypted traffic. That's why we have put a lot of energy in traffic encryption detection and analysis, because this is where the internet is going. And just to give you, to make an example, to give you an idea of what we can do, whenever we have a flow and we can label the traffic and we generate a risk. So in this case, we see, for instance, two flows. Okay, in the first flow, we see an encrypted TLS communication where we have a self-signed certificate and an obsolete version. So it means that probably this traffic is suspicious, and many malware are using this type of techniques to exchange data. In the other example below, so you will see this is an HTTP communication, so it's clear text, and we see a transfer of a binary application. So it means that somebody it is downloading a binary, an executable, and this is something that is usually bad. That is an indication that there is something bad happening in the network. So these are two examples that we want to show you, just to understand the power of NDPI, that it is much more than simple deep packet inspection. And if you want to know more about that, and if you are also using Wireshark, we invite you to join the Wireshark conference next month, so in about 15 days, that it will be online, where we'll be talking about the integration of cybersecurity techniques into Wireshark. And the idea here is to give you an idea also how we can use Wireshark in this area. But I'll let you join the Wireshark conference to know more about that. So in essence, once we have a flow risk associated with communication with a flow, the idea is to turn this into a score, into a numerical value, that allows us to understand how bad is the problem, okay? And score 0 means no problem. A high score means a big problem. And this score that is originated on the flow, it is propagated also to other elements of our system. So that, for instance, to a user interface, so to a network interface, to a host, or to a customer. So if a customer is the integration of or the union of various hosts, or to an autonomous system or a country. Let's make an example. Suppose that we receive in our network many flows that are risky from a certain ESN. So in order to understand what is happening, we don't want to focus only the analysis at the flow level, because it might be too granular, might be hard to understand what is happening. But instead, we want also to make an analysis more at the autonomous system to understand where the threats are coming from, if there is a country or if there is something isolated by a single host. So this is the idea, to propagate the score that is based on the risk and that is based on the flow risk to everyone, to every component. And in essence, to give a numerical value to all those components that allows us to understand what is happening. In order to do that, NDPI gives a severity to each of the threats and a score. And this score is computed on all the various risks that have been identified. And in essence, the flow score is the sum of each individual risks, okay? So in this case, we have a score value of 80 for this AnyDesk communication that is happening in our network. And based on that, we have also the ability to enrich the score. In particular, this is a screenshot from ntop that allows you also to generate other type of score, and you will see this in the demo later today, that enrich the flow score. So that, for instance, if there are flows that are neutral, okay, but if they are done in a certain way, such as a port scan, so our application are able to understand that every single flow, it is not bad, but the union of those flows is bad because it is a scan. So this is how we complement the flow score with other type of score generated by observing flows from a certain host or network or ports, and to increase the flow score. And when we have a score, we sum the score per host, just to give you a score indicator that allows you to understand what is happening, what are the hosts that are more likely to be the source of the problem, or to be the target of this attack, okay? So that it is very easy to understand what is going on. And if you look at this picture that our friend Martin has created, you see that inside ntop, this is from ntop, you will see very quickly if your network is healthy, if there are issues that are very important, so the red one, if there are other issues that are less important but still issues, the yellow one. So this is how the score works. And based on that, so in essence, we can generate alerts, not just about the problem that we have identified. So let's say communication, over a non-standard port. This is probably a very minor issue, but we can also generate more important alerts, such as the one I've shown you before, about downloading a binary application that can be definitely a problem in many networks. And in addition to that, we have implemented in NDPI, and this one it is used by ntop, also the ability to analyze behavior. So this means that in addition to individual threats, individual issues that we identify by analyzing the traffic, we also look at the shape of certain time series. And then based on that, we trigger alerts. So in this picture, okay, we are depicting the client score. So it means that the score that is created by a host when, as a client, contacts other hosts, okay? And you will see that the score here is changing. Okay, so it's something around 50. Then at some point becomes 200, and as a peak and 2 other peaks. Okay, so what we have done is that we have implemented in NTPI, and again, these are used by ntop, but in general can be used by everyone because these are techniques in an open source library. that allows us to understand what is happening. For instance, look at this peak. If you see this picture on the left, is the zoom of the picture. You will see that the library predicts two values, the upper and the lower bound. And if the green value is between the two boundaries, okay, the library says this is good. Okay, so it's a value that is somehow expected. But if the value exceeds those boundaries, it means that there is something wrong happening, and we believe that this is something that is more important to analyze. Okay, so this is yet another way to contribute to the score, based not just on a single communication, on a single flow, but also on the behavior. So we want to complement all of that. And this makes easy to understand, in particular, if you are under attack, or if you're attacking your network is attacking other people, with visualization of what is happening. So let's have a look at this one. This is a map that is present in every ntop version. So you will see that, for instance, here on the right side, you will see the ability to have this drop-down menu to select, criteria for depicting the information. In this case, is host score. So you see at the bottom, you see score as an attacker, a score as a victim. So ideally, all the machines should be close to the origin, should be here, a low score value and close to the origin, everything looks good. Those outliers, so those hosts that are far from the center, are definitely special. Okay, in this case, you will easily find spot the attackers. So in ntop, if you click on this bubble, I've hidden the IP address, but if you click on this bubble, you will jump to the host that is creating this problem. And here, the same for the victim. Of course, we trigger alerts, but also if you want to understand graphically what is going on, this is another possibility. Another thing that we have implemented is detection of lateral movement. That means that when you are in a LAN, so this is inter-LAN traffic, east-west, if a host is contacting other hosts on other protocols that are not being observed in the past, this is called lateral movement. That might be an indication of somebody or some host that is doing or is performing some actions that were not performed before. So in essence, we keep in memory this information, and whenever we see that a host is performing a new connection on using protocols or IP addresses, target IP addresses that have not been used before, we label this as something special, okay? And there is a default in ntop that allows us to say, okay, this is bad or this is good, or leave it there as, because a human has to decide whether it's good or bad. And whenever we see traffic that has not been marked as allowed, this is also used to increase the score, and therefore to give us, a way to spot those machines that are doing, let's say, connection or actions that were not expected based on the past, let's say, traffic. Another feature that we have implemented is beaconing detection. Beaconing, in essence, are connections that happen periodically, so with a certain pace over time. So, for instance, they can be an indication of some monitoring activities. So, in my case, my Mac was pinging, every 3 seconds another host. This is used by the ntop active monitoring. But also, my host is doing, every 2 minutes some activities. If you look at the protocols, if you see what are the protocols, you might say, okay, this is my mail application that is fetching emails, so this is perfectly good. But if you start looking at periodic activities on unknown protocols, or that are based on protocols that are, let's say, special, like IRC, this might be an indication of an issue. So these are just new ways to increase the score, and therefore to have a numerical value that tells us whether there is something bad happening or not. So based on that, we said we could enforce the traffic, not just monitor the traffic and trigger alerts as we traditionally do. So we have started to do something along those lines in 2018, okay, when we have introduced, let's say, an online version of inline version, of ntop called enrich. And enrich, in essence, it is doing network traffic monitoring and enforcement. So it means the traffic goes inside ntop edge, and whenever this traffic does not comply with the rules, we block this traffic. And this is one of our products. It's very sophisticated. It can be used in various ways as a router, as a transparent bridge, in a container. So it is, let's say, per se, a sort of Linux distribution, because whenever you install enrich allows you to configure the network, to set the policy, to set also the policies on traffic, so traffic shaping. And so per se, it's a sort of intrusive solution, okay? Because it is doing a lot of things, and also it is based on ntop. Therefore, if I look at the limitations, we can say, first of all, that being a complete distribution might be heavy for some people, because you simply want to add a new component and not just to replace everything. It is designed for mid-sized companies, where you have two means twin, okay, internet link. It is not really designed for a distributed network. And the last problem is that it is Linux-centric. So like I said, in the second part of this presentation, we talk about pfSense and OPNsense. These are two important platforms used by many people. We would like to support them. And enrich is really Linux-centric. It's not possible to bring it there. So we said, why don't we take advantage of mprobe, that is lightweight, let's say, network sensors that we developed since a very long time. Actually, it's one of the oldest products we developed. And in addition to do what it is traditionally doing, so namely collect packets or flows and turn it into JSON or to other type of flows if we want to convert them, why don't we do that? So we take mprobe and we enrich mprobe with the things I've shown you before, so with the risk, the score, and so on. And we look at mprobe not just as a tool for network monitoring, but also a tool for enforcing network policies. How do we do that? We have done it in two different ways, because the two main platforms that we support today, Linux and FreeBSD, are a little bit different. On Linux, everything works based on something called NFQ. So in essence, you have to configure, and this is an example of a script that comes with mprobe. So everything is prepackaged. You simply have to fill up here the name of the network devices, and that's it. So in essence, we tell to the kernel, whenever there is traffic happening, okay, mprobe is becoming a sort of marker, a labeler. So it means that the traffic that is coming is marked by mprobe according to some policies I will now talk in a second, with a marker, okay, so with a numerical value. And based on the marker, the kernel will honor this marker and can, for instance, have traffic shaping, can have pass or drop. And the only packets that are going to mprobe are the first few packets that are necessary to do DPI. So it means that if you have, let's say, a UDP-based protocol, probably one packet is enough. With HTTP, probably you need 5, 6. With the TLS, you probably need about 10, 15. But that's it. Everything else happens in the kernel. And the kernel, as you can see with these red lines, implements some sort of bypass. So it means that whenever we pass to the kernel the marker, the kernel does the bridge of the traffic. So this is a transparent bridge example. In particular, if you have systems that are system on chip, they can exploit offload. So it means that those packets don't even go to the Linux kernel, but are simply bypassing the kernel for high speed. On FreeBSD, the story is a little bit different. Actually, it is much different. We have to interact with the networking stack using a library called ntop. So in essence, contrary to the Linux version where we have the ability of looking at the first few packets of our communication, in FreeBSD we have to analyze every single packet. So every packet will go to mprobe. Mprobe will decide whether the packet should pass or not. And if the packet will pass, it is bridged in 0 copy. If not, the packet is dropped. But the drawback here is that mprobe has to inspect every single packet, whereas in the first case, nprobe inspect just first few packets of a communication, then everything else happens inside the kernel. And this is very important for performance because, for instance, in this example, we have taken two systems. One is a very low end, and one is, let's say, mid performance system. As you can see, with the low end system, you are able to do 500 to megabit, 500 to 600 megabit with nprobe or with the vanilla bridge. So in essence, nprobe will not put too much pressure. Actually, it will accelerate a little bit the vanilla bridge because it is possible to distribute the traffic across multiple cores. Whereas with FreeBSD, because we have to merge every single packet, the performance will drop from 1 gigabit to 120 megabit. So this is the problem. Okay, we have done this test with bad traffic, so probably in reality it will be more than that with big packets. But in general, you will see that with Linux there is no degradation. Actually, probably there is some improvement. And with BSD, you have to expect at least a degradation because we have to inspect every single packet up and down. If you look at Linux at 10 gigabit, you will see that in essence we are able to do 10 gigabit line rate of transparent bridging with no effort, without introducing any delay. So still being able to do 10 gigabit. So this is very important. And now, if you're wondering how you configure that, so we have added a new field, a new command line option, sorry, to nprobe, called IPS mode. In this IPS mode, you have to specify a JSON file that is created this way. So in essence, it is divided in two parts. The first part is the pool definition. So here you create a pool of hosts for which you see something special. It can be IP or Mac based. Mac are very important for DHCP systems, and IP for others. Where you say, okay, those hosts for us are important, and we want to apply a policy to them. Okay. So once you have created the pools, you will specify a policy. Okay? In this case, in the first pool, you will see some IPs, an IPv6 address, and no MAC addresses. In the second pool, you see 3 MAC addresses. Here you will see a network. And as you can see, here you specify a policy ID. Okay, in this case, policy ID 3. In the second part of the configuration, you will specify the policies. The idea on the policies is the following. We can create a root policy that allows you to, let's say, define some defaults, and all the other policies can inherit, if you want, from this root policy, so that you can avoid configuring everything by hand and simply putting exception in this protocol, in these policies. In this example, as you can see, we can say, okay, HTTP will pass, okay, traffic towards countries, Italy will pass, China will drop. If you say Asia traffic will drop. This because when we have, let's say, here creating a pool, we're putting a pool, let's say, relevant system that we want to administer. So we're based in Europe, for instance. We would like at least to restrict from the geographical point of view the geolocation. Also, we want to restrict the protocol. So in essence, our idea is that we don't want to create a firewall replacement because our software will be based on the firewall. The firewall will block or allow you to pass traffic based on the 5 tuple. Here we want to go more into the behavior. We want to say, and you would see this in a demo, if you see something bad happening in this traffic, let's say the TLS certificate is mismatching, the certificate is sold, things like that, drop it. And this is what we want to do. So in essence, here in the flow risk, you can specify what are the things that you don't like to have in your network. Or if you see here host names, these are host names that are enforced or not inside the DNS, TLS, QUIC, every protocol that NDPI supports. So for instance, you can say things like YouTube will pass, but the Google static will drop, this type of things very easily. Now, this policy can be somehow difficult for people to edit. That's why we thought that the best for us is to enable those policies through ntop that, as a user interface, this is the first problem, and also that it is able to, in addition to our policies, to block host through this mechanism in case score for specific host goes too high for quite some time. So therefore, in case we see some sort of attack, okay? So the idea is to interconnect ntop with mprobe through 0nq. That is the protocol we are already using for other needs inside the ntop infrastructure. And do what? So to inform immediately as soon as we see a problem, the mprobes to block the traffic. Very similar to what a popular tool called fail to ban it is doing. So in essence, whenever we see a host or a set of hosts that are somehow special that we want to enforce, the system, if instructed, Matteo will show this in a demo later, will automatically do the blocking without you having to do anything. And this means that we generate an alert, so you can receive it on, let's say, on Slack, on Telegram, or via email, and at the same time be protected because we can protect you automatically. Just to give an idea of some use cases. Things very simple for many people have asked us, let's say, drop Tor or block, let's say, unclean traffic, like the one I showed before for this download of executables. Or let's say shape traffic, let's say assign specific bandwidth to, let's say, BitTorrent or to streaming protocols. And this is very relevant for many ISPs today, in particular wireless ISPs that are overwhelmed by streaming traffic that is becoming a big problem for radio-based protocols. Let's say preventing specific hosts from being accessed from countries, unwanted countries or unwanted continents, or drop traffic that has been labeled as malware, for instance, or for instance, assign fair bandwidth to specific protocols. This is something we have done last month with a Canadian ISP that is using this tool to assign fair bandwidth to Netflix, Disney, or other streaming protocols that were creating troubles because at some hours today were using too much traffic. Or block, let's say, advertisement servers similar to Pi-hole or blacklisted hosts, so you can have, let's say, a cron job that every night downloads a new blacklist and say, and probe, okay, please enforce the traffic based on the blacklist. And because we want to do this, in every mprobe application, we have decided, we made some decisions that are basically highlighted in this slide. We don't want to have any cloud access. We don't want to, send people traffic somewhere, on the internet just to make a decision. But everything stays local. So it means that mprobe will make decisions locally, same as ntop, no cloud access. We don't want to charge for this feature. For us, it's a nice way of identifying threats, also to clean up, networks, using our tools. And so we said we don't want to charge extra for this feature. So if you are already an existing mprobe user, you can get it for free. It's a new feature that is coming out of the box, so use it. The difference between the various versions are the number of rules. Okay, the higher is the version, the more rules you have. But every version, such as the Pro version, is definitely enough for protecting a company, a home network, or everything. And of course, we don't want to charge. We have never charged education and no profit. So the idea is to say, okay, in addition to what we have already done for network visibility, we also do now traffic enforcement. Of course, this is a new tool. At the moment, it is available on the dev branch. So you can have it and you can install it by using the development version of ntop packages. So you go to packages.ntop.org and you take the Untitled builds, and it's part of that. We plan to integrate in the stable release next month, or probably early July, so that everyone can benefit of it. Also, we still have to make some improvements. So, for instance, at the moment, the enforcement on the service and periodicity map, it is only based on the score, whereas in the future we can probably add something extra, to do more, let's say, using the policies of the service map to put some sort of enforcement. So let's say if this host is doing, let's say, HTTP, and today it wants to do HTTPS, but HTTPS is not something we allow in the past, we block it. So this is something that we are developing. And also we would like to create some policies, probably in the following release, based on the device type. So let's say if I have an Alexa device and Alexa has to speak with certain host with Amazon, and if I detect another Alexa device that looks the same, those devices should have the same policies out of the box. So once we have identified those devices, we can say the basic protection is this one. Then if you want to add exception, you can do that. You will see in a moment how to do that. And of course, before the release, or let's say for a future release, we would like to hear from you after this presentation, so that you can comment, you can report us, new ways for implementing this type of features. So that's all for now. I would like to acknowledge the AGI Trust European project that allows us to develop some of those features. Silicom and Vexo that supported us in this development. And now I leave the stage to my colleagues for a demo and a demonstration of the features. Please, Alfredo.
Yes, thank you. Let me share my screen. Can you see my screen? Could you confirm you can see my screen, please?
Yes.
Yes,
okay,
yes.
Great, thank you. Okay, so my name is Alfredo Cardigliano. I'm part of the core team of ntop. And today I want to show you a live demo. I want to show you how to configure ntop-ng and nprobe, especially in IPS mode, on two platforms, mainly on OPNsense, which are the two of the most common security-oriented platforms used today, as Lucas said before. So the agenda is I will show you how to configure our repository for installing our software on OPNsense, pfSense, how to install our plugins on OPNsense, how to configure nprobe, how to configure ntop-ng, how to configure nprobe as a transparent bridge in IPS mode, how to integrate nprobe with ntop-ng. So in order to use ntop-ng for the policies configuration, and talk with nprobe in order to propagate, to export the policies to nprobe. Okay, so let's start. So as first step, in order to install our software, you need a terminal. This is just for adding our repository. After that, you can forget about the terminal and just use the user interface in OPNsense. Instead, on pfSense, you still need to install the packages and configure them using the command line. So in order to install the packages, you need just to, let me show you the shell. So you need just to log into OPNsense, type A to get the shell, and run the command that was in my slides. So the package add with our repository. You run this command and you have our repository. So now you can forget about the terminal. You can just go inside log in your web interface on OPNsense, and you can go to install our plugins. So you go to systems, system plugins, sorry, firmware plugins. Here you update the plugins, and you get in this list ntop-ng Enterprise and nprobe. So you click just on the plus icon. Now it's already installed, but you can just click on the plus icon and you install the software. After that, you will get the software configuration user interface here. So you get ntop-ng Enterprise and nprobe. So let's see, for instance, nprobe. You go to nprobe settings. And here you have a bunch of settings. So you can configure the interface where nprobe will capture the traffic and process it, analyze it. And you have a ZeroMQ endpoint that you can use to send traffic information to ntop-ng. By default, this is on the local host, so you can run ntop-ng on the local host, but nothing prevents you from running ntop-ng on a different box in order to reduce the load on this box, on the OPNsense box. So you just run nprobe as a sensor here and run ntop somewhere else and send traffic information. And then there is some more configuration for the IPS that we'll see later in this presentation, in this demo. Then you can go to ntop. In a similar way here, you can directly capture from interfaces. So you can let ntop process live traffic from the interface, or by enabling this flag, you can collect traffic information from nprobe. And you can configure the ZRMQ endpoint where the traffic information will come. Now, you can just run the service and use this link to connect to the ntop user interface. So here you usually select the ZRMQ interface, which is this TCP, and you can start monitoring the traffic. So you can look, for instance, at the flows. Here you have a box which is currently connected to internet using this OPNsense box. So if I go on Facebook, for instance, you will see here some Facebook traffic. It takes a couple of minutes probably. So because nprobe now is running as a sensor, is processing the traffic and is sending periodically traffic information to ntop. So you should see some Facebook traffic soon. Now, in this configuration, you are just monitoring the traffic. So you are, let's say, visualizing the traffic. Now I'm waiting a little bit to show you the traffic that we're processing. Here you go. So you see the Facebook traffic. Now, as Luca said, nprobe is now able to run in IPS mode, so inline as transparent bridge, able to process live traffic. In order to do that, you go to the nprobe settings, and you have to enable the IPS mode here. Now, you have two ways for enforcing the traffic. You can manually configure the traffic policy using the JSON format that we have seen, and you can cut and paste here a configuration, for instance. Or you can configure the traffic policies in ntop using the web interface and get directly, automatically, let's say, from ntop the traffic policies. In order to do that, you should enable this special ZRMQ endpoint. So you have to specify, hey, I want to collect IPS events from ntop, and this is where I should connect to get the events. The same way you go in ntop, and you configure ntop to publish IPS events, and this is the ZRMQ endpoint where the events are published. Now we can go to ntop and start configuring the traffic policies. In order to do this, we have to go to the pools. The pools in ntop are groups of hosts. So a way for grouping hosts with the same homogeneous hosts, let's say, so hosts which are similar, and apply policies to those hosts. For instance, here we have two pools, the IoT devices and this pool called team. So if you go inside this pool called team, for instance, you can, so you go and edit the pool. You can add hosts from your network based on IP address, network, or MAC address. For instance, let's add one more host here. And using this key, you can configure the policies for those hosts. So we can go inside, and you have the policies. Those policies are exported to nprobe for actually enforcing the traffic. So here you have a default policy. So by default, you can have a pass policy, or you can decide to use a default deny with drop and just allow selected protocols, or you can set this as pass and discard selected traffic. So you have both options. So here you can apply specific policies based on the layer 7 protocol. For instance, I want to drop Facebook. Or based on the layer 7 category, which is detected by NDPI. For instance, I want to block advertisement. Drop it. Or maybe you want to slow down BitTorrent. Slow pass. Or you can apply rules based on the host name. For instance, I want to allow times.com. Or by country, as Luca said before, I don't know, you want to blacklist China, for instance, just to pick one. Or continents, so Asia, whatever. Or you can add policies based on the risks that NDPI detected. For instance, I want to drop SQL injections, or I want to drop traffic detected as suspicious file transfer, like binary transfer. Now you can save this. And you can go here, and you have two options. You can download the policies. Let me download it. I will show you the format. It's the same that you have seen before. So let me another window. Okay, so this is a file that I just downloaded. So as you can see, you have this is the format that we have seen before in the presentation that Luca gave. So we have the pools definition, we have the IP address that we just configured like this, and we have the policies definitions related to the pools. Here we have the Facebook protocol, for instance, drop, and these other protocols, low pass, and China drop, etc. So now this policy has also been automatically sent to mprobe, which is connected to this ntop-ng instance. So for instance, this machine that we just used to check, for instance, to run some traffic to Facebook, is one of the machines configured here, and we just dropped Facebook. So if I go to Facebook, it doesn't work because we just dropped the traffic. Another nice feature, for instance, we have this group of IoT devices. So I can go and configure the policies for the IoT devices. IoT devices are usually supposed to use a few protocols. So it's probably better to use a default deny policy here and configure the protocols that the IoT devices are usually using. But we want to do this automatically because probably we don't know exactly what the device is going to use. So ntop-ng can do that for you automatically. So ntop-ng is learning what those devices did in the past days, and you can use this auto-configure button to get a policy that contains the protocols. I think I don't have enough traffic here. So you usually get here the layer 7 protocols and the host names, for instance, that those devices did in the last days. And you get a bunch of risks that are really important to drop for an IoT device, and then you can just add more risks here. This policy is already saved, unless you want to change it. And yeah, that's it. This is a feature we are working now, and we think it's really useful. What else? Yeah, as I say, this configuration is directly sent to mprobe, so you don't have to do anything. But if you have an mprobe instance which is not directly connected, through the events channel to ntop-ng, you can still download the JSON here and cut and paste the JSON under the mprobe configuration, which is here. So in this case, we are using a static configuration so that you set manually, but it's the same behavior. Okay, I think I'm done with my demo. Now my colleague Matteo will show you how to automatically generate policies for dropping traffic towards hosts which are considered bad, let's say, because, for instance, they have an high score, which is an indicator of bad reputation, let's say. Matteo, are you ready?
Thanks, Alfredo. Can you hear me?
Yes.
Great. So let's share my screen.
Close my screen.
Can you see it?
Yes.
Yes.
Great. Hello everyone, I'm Matteo, and like Alfredo and Luca introduced before, today I'm gonna show you the new feature that we developed, a system that automatically ban hosts that behave strongly inside your network. Now, this new feature is going to use three main points: the alerts, the score, and the ntop IPS. This system is going to understand, thanks to the score, if an host is behaving wrongly or not inside your network. In fact, an host with a high score probably is doing something bad inside your network. And in this way, the system is able to understand that, all right, this host has a high score, let's ban it. An important thing about this system it is that it is not going to permanently ban an host. It is just going to momentarily ban that specific host, currently for 15 minutes. So let's take a look at how we can enable this system. Like I said before, it uses the alert system, so it is an alert. Let's go into settings and use scripts, and this is the alert I'm talking about. By default it is disabled, so let's disable it and re-enable it. And to enable it, you have to click the green button, and from here you can configure the alert. Now, like I said before, it is going to use the score, so this is the threshold. In this way, if an host exceeds this threshold we configured in this page, so for instance 1000 for example, then that host is going to be banned using the ntop IPS. Now, an important thing about this system is that it is not going to instantly block an host that exceeds the threshold, because sometimes happens that an host just has a problem for a few seconds and its score spike, and it goes beyond, it crosses the threshold for 1-2 seconds and then go back. And this is not seen as a really dangerous host, but instead the really dangerous hosts are those hosts that continuously cross the score. In fact, if an host is banned if it crosses the score for over 5 minutes consecutively. So let's enable this alert, and here we are. Let's check it out, and as you can see, it is enabled, and you can change obviously the threshold as you like. Now, like Luca and Alfredo told you before, this ntop IPS is going to use the pulse system. So this alert 2 is going to add a new special, let's say, pool called jailed hosts pool into your pools. So let's go into the pools page. You can go there by clicking shortcuts pools, or just by going into system, pools, and pools. And here we are. As you can see, we have the pool I was talking about, the jailed host pool. This is a special pool. In fact, we cannot delete it nor rename it. And for instance, however, you can modify its member. You can change its member. So, like Alfredo showed before, you can add a new member, just like a normal pool. For example, let's add a new IP. And as you can add them, you can even remove them. Now, an important thing is that this system is going to automatically add hosts into this pool. At the same time, you can manually add them, just like I showed you before. But the one removed automatically, because like I said before, the hosts are going to be unbanned after 15 minutes of being banned. The only one that are going to be unbanned are those that are automatically banned. So those manually added are not going to be automatically unbanned. For this reason, you can see it just like a permanent ban. Obviously, you can even remove them, and just like you can remove the one manually configured, you can even remove the one automatically configured. And that's all for the automated new system that bans host. Thanks for listening.
Okay, this is basically the end of our presentation today. We wanted to give you a sneak peek of what we are doing and what we have developed. Like I've said, this is part of the dev branch. It is not yet part of the stable. It will be included in the next release that will happen soon. But if you want to start playing with it, feel free to do it. And I don't know, I try to answer questions on the chat, but if you have additional questions, please turn on your microphone and ask. We are here to answer you.
Hello, I don't know if you can hear me.
Yes, we can.
Yes.
Hi.
Hello, it's Gregory Bernard. I had a question. Do you have a schema of the communication flow for the new plugin? Because I've seen that there are a couple of ports that are used to communicate between the nprobe and the engine, and I would like to know if you have some kind of communication schema.
Okay, I want to show you my slide so I can probably clarify. So in essence, what is happening is the following: that we have a new 0MQ publish events, okay, channel.
Yes.
That it is basically one new topic, implements one new topic called IPS, and those nprobe basically listen to this topic, and whenever ntop engine starts up or there is a change in policy like Matteo shown, a new policy will be sent. So in essence, on this topic at the moment there is only one message, and the format of the message contains this rule. So Alfredo showing you a demo how to generate the policy, okay?
Yes.
And so in essence we send this one, so only this one, only this message.
Okay.
But again, we need your feedback. So what else would you like to receive, for instance, just to understand?
Yes, I was also interested in let's say that we work with some people that have like 170 or 200 firewalls, and they want to push these kind of rules.
Yes.
And as you know, we have a tool that is called Dynfile Manager that can help people to manage centrally their firewall. So I was interested in having a centralized point that could interact and push the policy. So I don't know exactly how this is possible. That's why I asked if there is an API available, or if it's possible to integrate that and interact with the various firewalls that would have the ntop, for example.
I understand. At the moment, we don't have an API, but in essence, we can, if this can help, you can publish a simple program, or C program. So whenever you start this program, nprobe, you can basically the code that is part of ntop-ng. Okay, the ntop-ng code is open source, so it's part of GitHub. But just to make this thing simple.
Yes.
So in essence, we implement a listener, okay, and nprobe, when you say 0nq publish events, will connect to the 0nq endpoint, and we'll wait for new messages. If there is a message about IPS, the IPS at the moment will be this one, and then probably will receive it. So if you want, if you have your own application, your own firewall, and you would like to also to subscribe to it, you simply have to open a 0MQ socket and connect to ntop-ng, and ntop-ng will send this data. If this can help you, we can write a small application that you can use for, for developing something on top of it.
Okay. Okay. Well, I think I will take some more time to like set that up and test it, but that's it's very interesting. Thank you.
You're welcome. Other questions?
Hi, my name is Bobby. I have a question regarding the applications which are supported. So if we have a specific requirement that we need to monitor a specific application which is not being supported, is there a way we can add rules or anything to support that application, or how is it?
Yes, let's say in NDPI it is possible to add new applications at runtime. So what is happening is we allow you to say, okay, this host on this port means this application. So for instance, in banks or in environments where there are custom applications, this is the usual way that we can identify new applications, okay? Problem number one. Another way of creating an application in NDPI is through strings, because today most of the protocols are stable. So let's say many protocols are HTTP, TLS, or quick based. Okay, and in essence, what it is different is the domain name you're accessing. So for instance, Disney Plus, so the streaming is just TLS traffic with Disney Plus on it. So it's possible to provide this config file. So this config file is supported by NDPI, so therefore it is supported by both nprobe and ntop-ng. So this is the standard way of creating new applications.
Okay, got it.
Okay, good.
Hi, Luca, I have a question.
Hi, please.
So nprobe flow to risk calculation. So how does this risk is calculated? Can this be changed or tuned according to the current environment, or is it fixed?
Okay, at the moment you're talking about the flow risk.
Yes, yeah, flow risk.
Okay, the flow risk at the moment it is fixed. Let me show you the slide again. So in essence, this is how we define the risk score. But what we can do is we can share the risk based on the client and the server. So let's make an example. So suppose you have a SQL injection, okay? So the host that is sending the SQL injection code, we can identify as the attacker. So we move most of the score towards the attacker and very little to the victim. So this is what is happening. However, the flow risk can be also complemented with other type of risk, like I showed you before. So in essence, this is computed statically because we want to have something uniform across all the possible system. In the past, it was more dynamic, but we had issues with various configurations because some people had different setups. So therefore, the idea was to make it fixed. Is this a problem for you? What do you think?
Okay, so when we are going to tag a flow with higher number of so high score of risk, then we should be knowing based on what grounds it was tagged to be severe or low, right? So
yes.
how do we know that information? So because what comes out of nprop is like a kind of something coming out of a block box.
Exactly. So, but this is just for the flow risk. So on top of this, you can add additional risks. And Matteo was showing you that in order to somehow to trigger a jail, you can specify the threshold. So let's make an example. So if you have a blacklist, okay, you say this host is also in a blacklist. Okay, this is another type of score that will be added on top of the flow risk. So regardless of the flow risk, if this host belongs to a blacklist or if this host is special for you, you can block it. So this is the way we have implemented. But if you have a suggestion, so if you have special needs, let us know, because
Sure. Okay. I mean, one thing, can we add a list of hosts to be blocked, and based on which the risk score can be computed dynamically? Is it allowed? Can we supply that list?
What list do you want to supply? Sorry.
The list of hosts to be blocked, maybe external threat intelligence feed using which I want to block certain IP addresses. So can I specify that in some format which nprop can understand and calculate a new risk score?
Yes, this is possible, and we usually don't block per host, but we block per category. So in essence, what you need to do is the following. In the I don't know if I have an example here, but I can send it to you. So in essence, here we have the ability of blocking or putting a marker. Okay, so block is just a way to characterize a marker. So in essence, we can block per protocol or per category. You can see here in this example, video category drop. Okay. So what you can do is the following. You can specify in a category file, okay, like ntop-ng is doing. So if you go inside ntop-ng, when you have the category list, you can find the blacklist. So instead of blocking one host one by one, so we create a category, let's say blacklisted host, and in this file you can put all the IP addresses or networks you want to block. So yes, this is possible. I'll add an example to the website, and it's probably relevant. Yeah, thank you for asking.
Yeah, that'll help. Yeah. Another thing, so do we have to have ntop-ng to configure this, or can I, without ntop-ng, can I interact with the system by just, making some configurations in some JSON file? Is that possible now?
Yes, it's definitely possible. ntop-ng is an optional component for people who like ntop-ng or use ntop-ng. But we have users, the example of this ISP in Canada, that had to give priority to their traffic or to block specific protocols. So in this case, it didn't use ntop-ng for pushing the routes, but it was using ntop-ng just to understand where the traffic was used and then to configure the routes. So those routes were configured by hand. Yes, ntop-ng is an optional component.
Thank you.
Okay. Other questions?
Yes, maybe I have another question. When we discussed the plugin, you showed the difference in performance that there was between the FreeBSD and the Linux systems. Is there any plan to try to increase that, or what are your the action that you might want to have in order to enhance the performance of that?
The problem of FreeBSD is the design, because in essence, in FreeBSD, you have to send every packet to the application, and the application has to report back. So this is the main problem. We can try to improve it, but I don't really see a lot of room here, because in essence, inside the Linux, so what you do is that you send to the application only the first few packets, and then as soon as nprop is happy, nprop sets down a rule to the kernel that says, don't send me any more packets belonging to this flow, because I already made a decision about pass, drop, or shape. Instead, this is not possible on FreeBSD. And this is another limitation of FreeBSD, because, for instance, on FreeBSD, at the moment, we are not able to shape the traffic. We can only say pass or drop, okay? So I don't know. I think this is going to be complicated to fix. We have to look at it again. We see, for instance, that people, the pfSense people, they have created a totally different product for high speed. So
Yes.
I don't know. We check again, but we are not super expert of FreeBSD. So if you have suggestions, please let us know.
I will follow up the discussion.
Okay, by mail if you want.
Yes, exactly. Yes. Okay.
Okay, thank you.
Thanks a lot.
You're welcome.
Yes.
Alfredo, there is a question about OPNsense in the repository on the chat. Do you want to answer?
Okay, so is it possible to share the repository for OPNsense? Yes, but if you go on our website, you will get the link. Let me share it. I will share it. So in essence, if you go to the link that I just sent in the chat, you get the two repositories for BSD 12 and 11, and you can just select the 12 and use it for OPNsense. Any other question?
One question. If majority of the traffic is encrypted, then can we dissect the packets to find out exactly which protocol it is, the packet belongs to, or something like that?
So let's say, like I've said, most of the protocol today is encrypted, so 80% about. So yes, this is possible. And how do we do that? We look at the beginning of the encrypted communication where there is a certificate or at least hello between the client and the server. And based on that, we decide what to do. Just to make an example, when you access maps.google.com, even though the traffic is encrypted, we don't actually see the map. We are able to see the beginning of the communication, and this is how we know what is the protocol, and based on that we decide what in essence is the protocol behind it, simply because we have inside the NDPI a list of protocols based on the domain name. So let's say whatever Amazon.com would be Amazon, Disney Plus something would be Disney, things like that. And this list is automatically extensible at runtime. So it means you can provide a file. So let's say if you have luca.com, okay, is the Luca protocol. So you put in a file this list of protocols, and ntop and probol, every NDPI-based application can use it.
Okay, so basically it just looks at the starting of the packet or the starting of the head of the packet, and it tries to guess that, okay, this is coming from Amazon, or this is coming from Google.map, something like that.
No, it is not a guess. It is an exact match. So because it's part of the communication. Let me see if I can show you an example. Wait a second. Let me start up Wireshark. 1 second. But this part, this is something that NDPI is doing ready out of the box. So 1 second. Let me show them. Inside the NDPI, there are various there's various folders that contain, let's say, pickup files, so that are used for unit tests. So for instance, I take one of those. Let me now share the window. 1 second. So this one is Snapchat. Okay, inside this traffic, you see at the beginning there is this client hello. So inside the client hello, that is the beginning of the communication, you will see, for instance, information about the protocol itself. Okay, so let's now search for client hello. Oops, sorry, selected. Okay, inside the client hello, at some point there is also the server name. So let's have a look at it. So in this case, it's appspot.com. So as you can see, so this is how we know the protocol. So we simply go inside the beginning of the for TLS client hello, but quick is different, but is the same idea. And here is where we guess. We read the host name that you want to access. Yes.
Okay. Okay. Okay.
Thank you.
Thank you.
Good. Other questions? Okay, so if you want to ask more questions, you can always join our Telegram or Discord channels. So in the ntop ng is, in the ntop website, if you go to the community support, you can ask us questions every day and interact with the community. I want to thank you for what you have done here and for your support, for your feedback. Some of the users here today already interacted a lot with us to make this tool better, but we still need your feedback. So make sure that you can contact us and report what is necessary. Like I've said, we have done this all free of charge. We want this to be part of our tools for everybody, because we believe it is important to provide the cybersecurity feature to everyone. Both the presentation and the video today will be available online. Give us some minutes that it will be put on our blog and on our website. Thank you again for being here. And you want to know the Telegram link. So 1 second, I will show you the website. So if you go to ntop.org, let me share the screen again. If you go to ntop.org, you will see, okay, this is a website. You will see that here there is support, there is community support. Okay, so you can click here. And inside the community support, there are two options, Discord or Telegram. Okay, we are active on both of them. Pick which one you like most. So we prefer Discord because it is also possible to talk with people, to interact with people, share screen, but it's really up to you. And once you have joined the server, you can send us questions at any time. We will do our best to reply you timely. Okay. So thank you very much again for being here, and I hope to see you at our next webinar. Bye-bye. Have a good day.
Thank you. Bye.